humans and industrial robots working side by side safely. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Clara Vu, co-founder and vice president of engineering at Veo Robotics. Welcome, Clara.
Hi, thanks for having me.
So what does Veo Robotics do, and what prompted you to start the company?
So we build eyes and brains for giant robot arms. Another way of saying that is that we build custom sensing and computer vision that allows giant industrial robots to be aware of people in their space and to work collaboratively with them. I've been doing robotics for over 20 years now. Small mobile robotics at iRobot in the early days. I've done agricultural robotics. And actually the idea for this company came from my co-founder and our CEO, Patrick Sobolvaro, who had the idea when he was touring an automotive plant at another company over 10 years ago. And realized that if the industrial robots that they rely on that are so powerful and so valuable in those contexts could safely work with people, that they would actually be able to do a lot more and provide a lot more value.
Why was it so difficult at first to get a robot to navigate a living room? What problems had to be solved?
Are you talking about Roomba now?
Yeah.
Okay. I just like, wait, I've got my head in manufacturing and automotive factories and appliance factories. And I'm like, oh, right, living rooms. That is where I started. So the challenge about basically all human spaces is there's so much variability that we as humans don't think about at all. So having a robot that can bounce around your living room is easy, but having a robot that will not get stuck when it goes under a chair is really hard.
What are the functional and safety considerations that designers of industrial robots must consider today?
Industrial robots actually have a very long record of safety and safety systems. There's a standard, ISO 10218, which all robot manufacturers and people that provide equipment and factories that use industrial robots use, that lays out exactly how to build highly reliable systems that can be used to keep people safe from dangerous equipment. So we, not only do we follow those standards, one of my other co-founders is on the committee that is writing the next generation of those standards. And that's been really important to us from the beginning and in everything we do.
We've had cameras, LiDAR, and other positioning sensors for a long time now. Yeah. How does AI improve what can be done with those types of technologies?
So it's interesting. As I said, I've been doing robotics for a long, long time now. And over those 20 years, AI has meant a lot of different things. In many ways, the only real definition of AI that works is, whatever computers can't do yet. So back when we were trying to navigate a living room without getting stuck, that was AI. Now a lot of people use the term AI to mean machine learning. Veo actually doesn't use any machine learning at all. We deliberately don't do that because one of the things that you need for a safety system is algorithms that are deterministic and have well-defined failure modes, which machine learning notoriously does not. So we use a variety of deterministic computer vision algorithms, some of which are pre-existing, some of which we've come up with on our own to understand a space well enough to reliably let a robot move around in that space. I think one of the things, in addition to all of the wide variety of new sensing technologies that have become available, and in particular available at low cost over the past 5 or 10 years, we also rely on simply a massive amount of computing power. When you have, for example, 4, 6, 8 cameras providing 3D data with hundreds of thousands of pixels in order to process that kind of data in real time, in addition to sophisticated algorithms, you just need a lot of horsepower.
What technical challenge do you face today that, when overcome, will offer that next big step in industrial robotics?
So for us, it really does have to do with figuring out how to do this in a safe and reliable way. So what we're doing is, we're looking at the space, the work cell surrounding an industrial robot. We're figuring out where people are or where people might be, and we're controlling the robot so it doesn't hit the people. Now, grad students have been doing demos of this for years. The whole idea of, see somebody and don't hit them with the robot is not novel, but being able to do that with the level of reliability that you need to deploy it in production as a safety critical system requires just an enormous amount of very, very careful engineering. And once you can do that, once we crack that nut, which is really what we're doing right now at Veo, there's so many other ways in which humans and robots can interact with each other. You can imagine all kinds of things relating to force feedback and gesture recognition and just that deeper understanding of and collaboration between humans and machines, but none of that is possible if you can't get the person and the robot in the same space in the first place.
So true. Do your technologies have an application for delicate pickup and place, that kind of movement?
So sure, I mean, our technology is actually agnostic to what the robot is actually doing. We are concerned with where's the person and the safeguarding. Industrial robots are incredibly powerful. You know, they can lift, you know, hundreds of kilograms. They can move at 2 meters per second, but they're also amazingly precise. I mean, they are manipulating things with sub-millimeter precision. So depending on the application and the end effector and the programming, you can either do very, very delicate tasks or, you know, very, you know, brute force tasks. And that's why these robots are so powerful and so valuable in automation contexts. I mean, the one thing that's very important to understand is that while robots are incredibly good at a lot of things, there's a huge category of things that robots can't do. And those are things that require flexibility and dexterity and judgment. And that's why human-robot collaboration is so valuable, because even though we hear so much these days about automation and new kinds of automation, and we're automating all these things, in manufacturing today, there are trends like faster product cycles and mass customization that actually require more and more flexibility in manufacturing. And the most flexible resource that any manufacturing organization has is actually the human workers. So letting those human workers then take advantage of the strength and speed and power and repeatability of robots actually leads to the kind of manufacturing that we're going to need for the future of the kind of things we want to build.
Clara Vu, co-founder and vice president of engineering at Veo Robotics. Thanks for your time today. If somebody wants to connect with you, maybe they want to find out more of the work that you're doing, how could they do that?
Well, you can definitely check out our website, veobot.com, and you can find me on LinkedIn.
Sounds good. And if you guys want to find more of my interviews, they're right here on ZDNet or Tech Republic, or go to my website, tonyahall.net. I've got links to all my social sites. Thanks for watching.